Hello students, welcome to my channel Kirti Sikhyasram. Today we are going to discuss about Introduction to Euclid's Geometry, which is chapter 5, class 9. In this chapter we will study different definitions and different axioms and theorems. So before we proceed, we should know about what is geometry. So geometry is a word which comes from two words that are Greek words, that is geo and another is metrin. Geo means earth, metrin means measure. So we can write the definition of geometry as the measuring of earth or the study of measuring of earth is known as geometry. Okay. So there are several mathematicians who gave different definitions. So among them, Euclid is one of the best mathematician who gave different definitions in his book Elements. So he has given 23 number of definitions. 23 number of definitions in his book 1 Elements. This is the name of the book. Among those 23 definitions, we will study here 7 different definitions which were given by Euclid. So number 1 is the definition of point. So according to Euclid, a point is that which has no part. That means here part means length, breadth and height, right? So according to Euclid, what he stated that a point is that which has no part. No part means a point is a geometrical representation. It is a geometrical representation. So here is a point A. It is a point when we can say that when it has no length, no breadth and no height. Okay, so this is the definition of point. We can write a point is that which has no part, or we can write a point is a geometrical representation which does not have length, breadth or height. Okay, so next definition. So the next definition is a line is breadthless length. A line is breadthless length. That means we know this is a line. So this line has length. Let this is 5 centimeter. This line has length. AB is a line which has length 5 centimeter. But this has no breadth. So Euclid stated that a line is a breadthless length. In general, we can say that a line is a geometrical representation which have length only, no breadth, no height. Okay. So go to the third definition. According to Euclid, the third definition is the ends of a line. The ends of a line are points. That means if I draw a line, let this is a line which is AB, and the ends of these lines is always points. Okay, so here A is a point and B is a point. If I extend this, the ending part of this, let this is C. C is also a point. So according to Euclid, the ends of a line are points. Okay, this is the third definition he has given. Let's go to the fourth definition. According to him, a straight line is a line which lies evenly with the points on itself. What is the meaning of this? A straight line, we know that we can draw this straight line like this. The points on the straight line lies evenly. We know what is evenly means. It is a right proper manner. Evenly means, what is the meaning of evenly? In a proper manner. in proper manner, right? So the points on the line lies evenly with the points on itself. Okay, so this is the fourth definition. And what is the fifth definition? So the fifth definition or fifth statement was, a surface is that which has length and breadth only. Let us consider this surface. Okay, this is a surface, it has only length. A surface has only length because it is a two-dimensional geometrical shape. Like this is a surface A, B, C, D. So this is the length and this is the breadth, but it has no height. Okay, so the definition of surface is, it is that which has length and breadth only, no heights. Remember, no height. And the sixth definition is, the edges of a surface are lines. What is the meaning of that? Now the edges, these are the edges. We considered it as a surface. The edges of a surface, these are the edges of a surface are always lines. You can say that, sir, this can be a surface, right? This can be a surface. Yes, it is a surface, but it is a surface which is made up of small lines. This is a small line, this is a line, this is a line, small line combination. Okay, so the edges are always the edges of surface are always lines. Okay, understand? Let's go to the. So the fifth statement was, a plane is a surface. Remember, it is a plane. A plane is a surface which is a surface which lies evenly with the straight line. What is the meaning? Now if this is a plane, let this is a plane surface and this is a line, my plane is a line. If I put this line on the surface, each and every point of this line of this plane should touch the surface. So I can say that this is a plane surface. Okay, this is a rough surface, right? If I draw or if I put a line over here, there are some points which does not keep in touch with this line. So I can say that this is not a plane surface. But if this is a plane surface and I'll put a line on it, so each and every point of the line touches each and every point of the surface. So a plane is a surface which lies evenly with a straight line. This is the meaning of this. Listen, here it is a rough surface. If I put a straight line, there are some points which does not touch the line, or there are some points which are not evenly spread with the surface or with the line. Okay, but here each and every point of the line lies on the surface. Okay, this is the seventh definition given by Euclid. Okay, let us understand what is axiom and what is theorem. Okay, so here, what is axiom, what is postulate, and what is theorem. Okay, sorry. So we know that axiom and postulates, these both are universal truths. Both axiom and postulate are universal truths, but the use of axiom and postulate are different from each other. That is, axiom used everywhere. Axioms used, it is used everywhere. But postulates use only in case of geometry. Okay, these are universal truths. Axiom and postulate, these both are universal truths, but axioms can be used in everywhere, but postulates can only be used in case of geometry. Okay, so what is a theorem? Now theorem are the statements which can be proved. But axiom and postulates can be proved because these are universal truth. These have proofs. We can prove these statements, but we cannot prove the statements axiom and postulate. These are universal truths and the uses are different. Okay, axioms used everywhere and universal truth postulates used in case of only geometry. Okay, understand? Okay, we'll go to the next. So Euclid has given 7 different axioms. 7 axioms. These 7 axioms are given by Euclid. So what are these 7 axioms? We will study one by one. So the first axiom says, according to his first axiom, things which are equal, things which are equal to the same thing are equal to one another. What is the meaning of this? Things which are equal to the same thing. Let this is a square. This is a square whose area is same, to the area of this triangle. Okay, and there is a rectangle. There is a rectangle whose area is also same to the area of this triangle. This is ABC. This is let ABC. Okay, so the area of this is equal to this and the area of equal to this. The things which are equal to the same thing, this is the same thing. This equal to this and this equal to this. This implies I can write area of square is equal to area of rectangle. Right, I can say that. Or let's take another example. Let the price of 3 mango is equal to price of 3 grapes, and the price of the price of 8 guava is equal to price of 3 grapes. So I can write from these two equations, I can write the price of 3 mango is equal to the price of 8 guava. Right? Understand? Okay, we'll go to the second axiom. Okay. So the second axiom is given that if equals are added to equals, then the wholes are equal. We know that 2 is equal to 2. So these two are equal. If I add equal, means 2 plus 3. Okay, and here also I will add 2 plus 3. So answer will be 5. If equal are added to equals, previously these two are equal. If equal things added to equal things, then the sum will be equal. Okay, understand? If equals are added to equals, here two things are equal. Let this is a thing and this is the thing. Okay, the similar thing is added to this, and the answer will be equal. Right, this is the meaning of his axiom 2. Let's go to the axiom number 3. So the third axiom is if equals are subtracted from equals, then the remainders are equal. Let Rama has 5 grapes and Sita has 5 oranges. If I subtract, or if I have took 2 grapes, number is 2 grapes from Ram, and 2 oranges from Sita, what are the numbers left? So if I subtract this from 3 grapes and here 3 oranges, the numbers are 3 and 3. If equals are subtracted from equals, then the remainders are equal. This is the meaning of this statement. Okay, understand? Let's go to the axiom number. The statement is given that things which coincide with each other are equal to one another. What is the meaning? If let us consider this is a surface. This is a surface. If another surface, if I put another surface upon it, if these two surfaces coincide, okay, if these two surfaces coincide, then we can say that these two are equal to one another. Let this is a line AB, which is 5 centimeter. Another line is CD. This is also 5 centimeter. If I put this CD upon AB, they will coincide with each other. Okay, we can't identify which one is AB, which one is CD, because they coincide with each other. If two things coincide with each other, they are equal to one another. This is the thing in equation in axiom number 4. Understand? Okay, we'll go to the axiom number 5. What is the axiom number 5? The statement is like the whole is greater than a part. Okay, let's consider I took a brick. So this is a brick. I broke it into 2 pieces. So this brick, this original brick, always greater than this part. Like this is 1/2 part, this is 1/2 part, or this is 1. We know that a fraction is always smaller than the whole. Right? The whole is greater than a part. This is the meaning. If I took something and break it into pieces, and the pieces are always less than the whole. Okay, this is the meaning of this thing. If you have an apple, if you bite an apple, it reduces, not okay, it reduces to small. So a part is always less than the whole, or the whole is always greater than a part. This is the statement number, or this is the axiom number 5. Okay, we'll go to the axiom number 6. So in axiom number 6, Euclid stated that things which are double of the same thing are equal to one another. That means, let this is a square. This is a square, and the area of this square is double the area of this square, small square. This is a big square and this is a small square, and the area of this big square is double the area of this small square, and the area of this square is also the double of the area of this circle. Okay, the area of this square is double the area of this circle, and area of this square is double the area of the square. So from here and here I can say that the area of circle is equal to area of this small square. Understand? This is the meaning. Things which are double of the same thing are equal to one another. Understand? So instead, in axiom number 7, the reverse has given things which are half of the same thing. Things which are half of the same thing are equal to one another. Right? So in this statement, the things which are half of the same thing. Okay, this is the thing, this is the area. Take this example also. The area of this square is halved to circle. This area of the square, if halved, it will become a square, and the half of the square and half of the square is a circle, and half of the square is a square, and the area of these halves are also equal. So things which are half of the same thing are always equal. So this is the axiom number 7. I hope you understand all the axioms. If you understand all the axioms, please like the button and do subscribe with your friends, because it is lockdown period. If you share the video with your friends, they will also understand, okay, and study. Okay, let's go to the next. Okay, let us discuss the Euclid's 5 postulates. So among these 5 postulates, in postulate 1, he stated that a straight line may be drawn from any point to any other point. In this world, if you take different 2 points from anywhere, like if this is a point here A and this is a point here B, you can take any 2 points and you can draw a straight line from these 2 points. Okay, if you take a line here and if you take a line in America, if you take a point in here, if you take another point in America, you can draw a straight line from America to here. Okay, so a straight line may be drawn from any point to any other point. This is the postulate number 1. Let's go to the next. So in axiom number 5.1, it is given that given 2 distinct points, there is a unique line passes through them. What is the meaning of this? Listen, if A is a point and if B is another point, we can draw thousands of lines or infinity numbers of lines can be drawn from these 2 points. Not straight line, like lines can be drawn from here to here. These are also lines, curved lines, right? But there is a unique line. That means this unique line is a straight line. There is a unique line always pass through these points. Okay, so this is the unique line. 1000 means infinity numbers of lines. Remember this point, infinity number of lines can be drawn between 2 points, any 2 points, but there is only a unique line which passes through A and B, which is a straight line. Understand? This is your axiom 5.1. Let's go to the postulate number 2. What it states that, so in postulate 2, Euclid stated that a terminated line can be produced indefinite line. A terminated line is this. Let this A be. This is a terminated line. Terminated means the last point are terminated. Okay, so it can be drawn indefinitely or it can be produced indefinitely. I can produce up to this. I can produce up to like this. So from here to infinity and here to infinity, I can produce both the terminates of AB indefinitely. So a terminated line can be produced indefinitely. In postulate number 2, it is stated that. So in postulate number 3, Euclid stated that a circle can be drawn with any center and any radius. That means if this is a point and this is the center of a circle O, I can take any kind of radius. I can take 2 as radius and draw a circle. I can take 5 as radius, I can draw a circle. So I can take a point here and I can draw a circle. I can take a point here and draw a circle. I can take a point in USA and draw a circle. I can take a point in president's house and produce a circle. So we can take or we can draw a circle with any center and with any radius. Like I can take radius as 1000 kilometer. I can draw the circle, right? So this is the postulate number 3 according to Euclid. So in postulate number 3, he stated that, or Euclid stated that, all the right angles are equal to another. We know what is a right angle. The angle whose value is 90 degree is right angle. Let this is ABC is a right angle. Okay, the value of this angle is 90. Let this is a big right angle and this is the PQR right angle. The Q is also a 90 degree. So all the values of right angle, whether it is small whether it is big, the value is always, or the angle is always 90 degree. That's why he stated all the right angles are equal to one another. Understand? Okay, let's go to the postulate number 4. Postulate number 5, sorry. Okay, what postulate number 5 stated? So the postulate states that if a straight line falling on the two straight lines makes the interior angles on the same side of it taken together is less than right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of angle is less than two right angles. Okay, we'll read the sentences and we'll draw. Okay, so here, if a straight line falling on two straight lines, here is the line L3 which fall on two straight lines L1 and L2. Okay, L3 is a line which falls on L1 and L2, and then it is written that makes the interior angles on the same side of it taken together. Let this is the angle and this is the interior angle. These two interior angles are produced. These two are interior angles also. But here it is given that if these two angles, the sum of these two angles, if it is less than 180, if it is less than 180, sum of, let this is the angle x and this is the angle of y. If x plus y is less than 180, then if we produce these two lines, these will definitely meet on the same side, on the same side on which the sum of angle is less than, because the sum of this angle is less than 180 on this side of the line L3. If we are considering L3, and this side of the line, left side of the line, sum of interior angle is less than 180, so these will meet on this side, not this side. If you increase on this side, or this will not meet. Okay, let us draw another picture. Okay, let us consider over here, this is a line and this is another line, and this falls on like this, and the interior angles produced like this and this and this and this. But we will consider, let us consider this and this. If this plus this is, this will definitely, we can see that this is greater than 180, but here this plus this is less than, this plus this is less than 180. If we produce these two lines like this and like this, here less than 180, so the lines produced will definitely meet on this side, like this right side, not the left side. Understand? This is the postulate, the fifth postulate of the Euclid. This is all about the postulates. We will go to the examples. Okay, after that we will go to the exercise. Let's do some examples given in your NCERT book. Okay, so here is the example number 1. Given that if A, B and C are 3 points on a line and B lies in between A and C, then prove that AB plus BC is equal to S. Let's draw the picture. So here is the A and B and C is a line, or AC is a line, where B lies in between A and C. We have to prove that AB plus BC is equal to AC. So in the above figure, we can see that the AC coincide with AB plus BC. So according to axiom 4, AB plus AC, AB plus BC. According to axiom 4, if the things which coincide with each other, are equal to one another. If AC coincide with AB plus BC, according to axiom number 4, we can write AC is equal to AB plus BC. Simply you can write here axiom 4. Okay, so we prove that this. only a single line you have to write that according to axiom number 4, things which coincide with each other are equal to one another. Okay, this is your example number 1. Okay, we'll go to the example number 2. Okay, so here is the example number 2. Prove that an equilateral triangle can be constructed on any given line segment. So we have to prove this, but before we proceed, we should know what is an equilateral triangle. The triangle in which all the sides are equal. So let's consider, we can prove this by, we can prove this by geometry method or by geometry. We can prove this by geometry. Okay, I will tell you the procedure. Let's draw AB is a line segment given. AB is a line segment given. Okay, take a compass, put one end at the point A. Here is the compass. You can take the compass and point out here and put the pencil here. You can draw like this. You can draw an arc like this, right? And putting the point over here, you can also draw an arc like this. The joint of this arc, these two arcs, you can join these two things, and this will be our answer. See, sorry, this mismatches. Okay, I will write down the steps so you can go. So here the steps are, step number 1. So we are considering a line. Draw a line segment. Draw a line segment AB. Second, take a compass, put the point at one end A and pencil on B. So you have to put the compass over here. If here is the pin and here will be your pencil. Then 3, draw an arc taking radius as AB. Similarly, in 4th point, change, take the compass point on B and pencil on A. Draw an arc considering AB as radius 6. The intersection point will be your C. 7, join AC or A to C and B to C. 8, so here B to C, and you can see that this will be a equilateral triangle. I will explain. Let A be here A and B. Put the point of the compass over here and pencil here. You can draw the arc like this and put the point over here and draw the arc like this. The joining point is C. And join A to C and B to C, and ABC will be your an equilateral triangle. This is the procedure, and pause the video and write the procedure like this. This is your example number 2. Okay, understand? So this is all about your Euclid geometry. In next video we will discuss the exercise. So for the next video you have to subscribe the channel and do share with your friends. Thank you.